Hello guys and welcome. On today's video I'd like us to focus on integration problems. So I'd like us to dive right into it without wasting any time. I won't be teaching the content this time around, I'll just be doing problems with you guys. So let's look at the first one. So they give us integral of cos into 4x plus 3. So in order for you to solve this type of problem, you see that the technique that is going to work is u substitution, okay? So what you say is that you let u be equal to 4x plus 3. Then when you take the derivation of that, the u, this one is gonna be 4. The derivation of 4x is 4, and the derivation of 3 is a constant, it goes away. Then dx, just like that, right? Then what you do, you make dx subject of the formula. If you make dx subject here, you're gonna get dx is basically equal to 1 over 4 du, isn't it? Yes. Then where there is dx in here, you're gonna plug 1 over 4 du, and when there is 4x plus 3, you're gonna plug u. Okay, then this integral simplifies to integral of cos of u, then where there was dx, you plug 1 all over 4 du. Okay, then 1 all over 4, since it's a constant, we can put it out of the integral. Then we have 1 all over 4 integral of cos u du. So this one now is a simple integral. Don't make a mistake of saying the integral of cos u is minus sin u. That one is for a derivation. So since you're integrating, it's just going to be positive, isn't it? So we're going to have 1 all over 4 sin u plus c. But then our initial problem was not in terms of u, as in terms of x. So we have to put back what was our u. We know that our u is 4x plus 3. Then we have to put that back there. So we have 1 all over 4 sine of 4x plus 3, then plus c. Then this is the problem, okay? This is the solution to the problem. So let's look at another one. This one is also still u substitution. So they gave us integral of cos root x over root x. Don't panic. What you have to do here is to test out your technique. If sometimes you don't know how to go around the problem and you know the techniques, test it out, okay? However, you can see that if we let u be root x, let's see what we're gonna get. Say u is root of x, okay? Then the derivation of that will give us 1 all over 2 root x dx. So I'm pretty much sure that everybody's familiar with what you call deriving. So that's why I'm not interested in showing you guys how this derivation, the derivation of this is that, okay? So if you don't know, feel free to try it on your own to see how it's gonna end up being something like this. Then what do? We want dx. So dx is there, we want to make it subject. So we have dx equals, we cross multiply, we get 2 root x du. So now this integral simplifies to integral of cos of root x is u, so it's cos u divided by u, isn't it? Then what is dx? Dx is 2 root x, okay? So it's 2 root x du, just like that. But then now we are integrating in terms of variable u, okay? And we see variable x there. So that thing is a problem for us. We want to write it in terms of u as well. So we remember that, oh, root x is basically u, so we can plug u where there's root x there. You see, I'm not rushing anything. I could have done that right away from when I was deriving here, but I'm trying to show you guys step by step such that some of you who are lost will keep in track, okay? So this 2 is a constant. I can choose to write it there since I'm not gonna do anything to it. So the root x, I said, is the same as u, since we let u be root x there, then du. So this u and that one, they are gonna cancel out. So you're basically integrating cos u du. Then we get 2. The integral of this, again, don't make the mistake to say it's minus sine u. When you're integrating cos, you're gonna just get sine u, okay? Then plus c. So basically, this is 2 sine, what is our u? Our u is root x, okay? So we go and say sine root x plus c. So that is the solution to the problem. Okay, so let's look at more problem that are relating to u substitution before we move on to integration by parts. Let's suppose you have integral of sine ln t divided by t dt. Okay, so if you have something like this, then you're like, oh, since it's sine and ln t, it's a composition in there, and you see that they're dividing by t. So what you can do here is to say this is the same as integral of sine ln t. I'm not yet solving. I'm just rewriting this thing in a way that maybe you can see the idea that you have to use here. Notice that ln t and this are related. What do I mean by that? If we derive ln t, we're going to get 1 all over t. So basically, we have to use u substitution, whereby this is going to be cancelled out after we derive ln t. Okay, so that is to say, if you say u is equal to ln t, then the derivation is going to be 1 all over t dt. Okay, so here notice even there is no need for us to make dt subject. We have 1 all over t dt, and we also have 1 all over t dt there. That means where we see 1 all over t dt, we can plug du. However, if you still wanted to go about the approach of making dt the subject, it was still gonna work. You are gonna get your dt you are gonna get your dt as dt equals to t du, isn't it? So if you get it as t du, and where there is dt, you plug t du there, this t and that one we're gonna cancel out. Okay, so you say we have integral of sine u, where there is ln t, you plug u, then du, right? Then that simplifies to minus cos u plus c. Notice that the integral of sine u is minus cos u. Okay, so don't forget minus cos u. Basically, if we derive this cos u, it must give us the function we have there, sine u. So the derivation of cos, we know it's minus sine. So minus sine times this negative here will give us positive sine u. So that is the idea, that the integral of sine u is minus cos u. Okay, so what was our u? Our u was ln t. So we have minus cos of ln t plus c, isn't it? Yes. So that is the solution to this problem. Let's look at another one. U substitution is not that deep. It just want you to know when to use it. If it doesn't apply, then you can move to using other techniques. There is more than one technique to solve integration. So let's suppose we have dt t ln t. Okay, so in order for us to solve this one now, we can see that, oh, it's almost the same problem we had here. Okay, don't get confused just because now it's t and ln t at both at the denominator. We know that we can say if we make u to be ln t, then the derivation of that will give us 1 all over t dt, isn't it? So if we get that, then we can cross multiply. So now let me use the technique of cross multiplying instead of separating these two to show that we have 1 all over t dt right there. So let me cross multiply and say that I'm making dt subject, then I'm gonna get it as t du. So where there is dt there, I'm gonna plug t du. So I'll basically have integral of t du divided by t, and ln t is basically equal to u. Okay, so this t and that one are gonna cancel out. So we're basically integrating 1 all over u, 1 all over u du. So it's 1 all over u du. What do we get? 1 all over u du, we get ln u plus c. Okay, so since we know that u is ln t, so it's basically the answer is ln of ln t plus c. Okay, just like that. So that is the answer to that integral. So suppose this integral had what you call it had let's say it had bounds where it was bounded from, let me say, e to e square. Okay, if this integral was bounded from e to e square, after we solve it here, then it was gonna be a definite integral. Let me write on the side what I'm talking about. So we got the answer is ln of ln t. And I'm saying if it was bounded between e and e square, then we are gonna plug e square in there, okay, and also e in there. So it was going to be ln of ln e square. Then we have to subtract the ln of ln e, then close bracket, just like that. So this one will become ln. The 2 can come down there, so we have 2 ln e, then minus ln of, what is ln e? Remember, ln e it's 1, so here we're gonna get 1. And also here, since we have ln e, we're basically gonna end up with ln of 2, isn't it? Ln of 2 times 1, this ln e is also 1. So that was going to be the answer if it was definite between e and e square. Okay, so yeah, that is all about the u substitution that I wanted to discuss with you guys. Otherwise, we can go on and on about it. Now let's move on to integration by parts. Yeah, so on integration by parts, we have to keep in mind if we are having product of two functions, then that is equal to uv minus integral of v du. Okay, so this is the formula that they use for integration by parts. So most people are confused of how to choose u. So basically you have to follow LIATE in order for you to choose your u. Okay, the one that comes first is L. So this L is for logarithmic function, either log or ln. Okay, then I is for the inverse trig function. So inverse trig is abo arccos, arcsine, arctan, things like that, right? Then A is for algebraic functions. A is for algebraic functions. Here about my x square, root x, things like that, isn't it? Then T, this T now is trig functions. Don't confuse inverse with trig. Here is trig. Trig functions, we are talking of cos, sec, sine, things like that. Then the E is basically for exponential functions. Exponential. Okay, so you're gonna choose your U from the one that comes first this side, going there, right? So yeah, that is basically the whole idea. You choose your U from here going there. Okay, so the first one is LIATE, just like that, following each other in that order. So let's suppose we are trying to integrate integral of let's make it a definite integral from 0 to 1 of x e to the power 3x dx. Notice that u substitution cannot work here. If you make u to be 3x or e to the 3x, that will not help you anyway, unless if this x was square, like 3x squared, then yeah, that was gonna work. However, now that can't work here. Okay, so following this, we have to choose our u. We're gonna use integration by parts. So we see that a comes before e, because here we're basically having algebraic and an exponential function. So a comes before e. That implies our u should be equal to x. Okay, so if u is x, then what is remaining is gonna be our dv. So dv is what is remaining, which is e to the power 3x dx, right? Then let's solve that. Du will therefore be equal to dx, because the derivation of x is basically equal to 1, isn't it? Then here v is equal to e to the power 3x divided by 3. So don't make that mistake. Remember, on dv we are integrating, so don't come here and derive. Integrate. When we are integrating, we have to divide by that 3. Okay, so now what do we get? You say, therefore, the integral from 0 to 1 of x e to the 3x dx is basically equal to, we are following this formula. It says uv minus integral of v du. Okay, so that is why I needed all this. I needed u, v, and du. So I got it as x. So v, I get it as 1 all over 3 e to the power 3x. Then minus integral of v. My v is 1 all over 3. I'm going to put 1 all over 3 here. Then e to the 3x. And du is basically equal to dx. From there, we can see that. So here I have to just put dx, isn't it? Then this will simplify to 1 all over 3x e to the 3x minus 1 all over 3 into the integral of this. We already know it. It has to be e to the power 3x divided by 3. Okay, so now I'm done integrating. I should not forget that this thing is between 0 and 1. Okay, so it's definite. So I have to say between 0 and 1, just like that. So if I sub 1, what do I get? I get 1 all over 3 e to the power 3 minus okay, sorry about that, I rushed the thing. So it's basically have to be 1 all over 3x times e to the power 3x minus, if I have to simplify this first, this is basically 1 all over 9, because 1 third times 1 third of e to the power 3x. Okay, so then here I have e to the power 3x from 0 to 1. Okay, so now I can start plugging in. So I am going to have 1 all over 3, then I plug 1 there, and I also have to plug 1 there, so I get e to the 3, just like that. Then minus 1 over 9 e to the power 3. So I've substituted 1 everywhere. Now I have to substitute 0. So if I'm substituting 0, remember I have to say minus of everything. Put the bracket there to avoid making mistake. So if I plug 0 here, everything this side is just going to be 0. So I'm basically interested in this side. So I'm going to have 0 minus 1 all over 9. Then if I plug 0, then I'm going to have e to the power 0. E to the power 0 is basically 1. So I'm having e to the power 0. Let me just write it down. Then here, these two, I can subtract them. So if I'm subtracting them, I'm ending up with 2 minus 1, everything over 9 times e to the power 3. Okay, then minus this minus by that. Remember, this is just 1, so this minus by that is just 1 all over 9. So plus 1 over 9. So this will simplify to 2 minus 1. No. It has to be 3. I'm trying to make the power, the denominator 9 there, so it has to be 3. 3 minus 1. So I get 2 over 9 e to the power 3. Then plus 1 all over 9. Right? Since both of them have the denominator of 9, I can say I have 2 e to the power 3 plus 1, everything divided by 9. Okay, so that is the answer to this integral. So let's do another example. Let's say we are given integral from pi over 2 to pi of x minus 1 sine x dx. Okay, so we have to first simplify here, multiply sine x by x, multiply it by also minus 1. Okay, so we are gonna see we have from pi over 2 to pi, then sine x by x is just x sine x, then minus sine x. Okay, then dx, just like that. So if we want to solve this thing, much simpler, we can separate the two. So you can say you're basically having integral from pi over 2 to pi of x sine x dx minus integral from pi over 2 to pi of sine x dx, just like that. So the integral of this one, we're going to have to use integration by parts, okay? And of this one is much easier. We know integral of sine x is just going to be minus cos. So this side is easy to solve. Let's work with this one, okay? So if you're in a test, then you're getting something like this. This is the way that maybe it can work for you to answer. So you just have to say for integral of x sine x dx, we're gonna say, since it's integration by parts, we have to follow that LIATE. Okay, so we see that we have A, an algebraic, and we have T, a trigonometric function. So A comes before T, that implies we choose our U to be X, right? Then what is remaining is sin x dx, that is going to be our dv. dv is going to be sin x dx. So if we derive this, what do we get? We get that du is basically equal to dx. Then here, when we integrate, we get that v is equal to minus cos x. Okay, so therefore, integral of x sin x dx is going to be equal to what? I have my uv, then it's minus x cos x. Okay, then minus integral of v, it's minus cos, so it's gonna make this thing to be positive. Okay, cos x, then my du is equal to dx. So I have something like that. So let's quickly integrate that. We have x cos x plus integral of cos x is just going to give us sin x. Okay, so don't go and say plus c. Remember, we took this part of the problem to integrate it on the side, and it's definite. Okay, so we therefore go and say, therefore, where there was this, we are going to plug that. Okay, so therefore, integral from pi over 2 to pi, I'm noting out this one, of x minus 1 sin x dx equals to integral of pi over 2. Now I'm noting out this one. Okay, so remember integrating this, so I took this to put it this side, and we know it was equal to that. Therefore, where there is this, it was equal to this whole thing. So therefore, where there is this, I'm gonna plug that. Okay, so this is the structure that you can use to simplify this integral. Otherwise, if you know, you can just do it from here. Just say equals to, then plug this. Okay, but then to avoid them deducting marks, show them everything. Okay, so they can see that you know your story. Then x sin x dx, it was also minus integral of sin x dx. Let's not forget, it's moving from pi over 2 to pi. Okay, so yeah, now where there's this one, we're gonna plug that. So it's basically going to be minus x cos x plus sin x, then minus integral of sin x, what is it? Is minus cos. So minus and minus will give us plus cos x. So they are going from pi over 2 to pi. Okay, so now let's see, when we plug pi, we get minus pi cos pi plus sin pi plus cos pi. Okay, I substituted pi everywhere where there is x. Then I have to subtract that from minus pi over 2. Now I'm plugging the lower bound. Minus pi over 2 cos pi over 2, right? Cos pi over 2 plus sin pi over 2, then plus cos pi over 2. Then I close the bracket like that. So now let's simplify this. What do we get? So cos of pi. Cos of pi is minus 1. So minus 1 times minus pi, we're just going to have pi there. Okay, we're going to have pi. Yeah. Then sine of pi is 0. Then you have plus 0. Cos of pi, we agreed, is minus 1. Then here, minus of cos of pi over 2. Cos of pi over 2 is 0. So this whole thing will go away. Then sine of pi over 2 is 1. Sine of pi over 2 is 1. So we get 1 there. Then cos of pi over 2 is 0. Okay. So it's 0. You can just say plus 0 or leave it out. Doesn't really matter. So we have pi minus 1. Then minus times 1 is going to give us minus 1 again. So this simplified to pi minus 2. So that is the answer to that integral. Okay. Yeah. If I lost you in between, feel free to rewind the video and look at the integral. Okay. And see how we build up to get to this solution of pi minus 2. Okay. So now let's move on to another example. Let's say they gave you something like integral from 0 to pi over 4 tan to the power 6x sec to the power 4x dx. Okay, so how are you going to go about this problem? Before we solve that problem, let us remember a few things about tan x and sec x. Okay, let's remember that the derivation of tan x is equal to secant square x. Okay, and the derivation of secant x is equal to secant x tan x, just like that. Okay, so remembering this, we are gonna use that idea to solve this integral, and also the identity that says tan square x plus 1 is equal to secant square x, just like that. Okay, so now let's deal with this problem. Okay, since we know that the integral of tan x is equal to secant square x, like I said there, then we see that we can break this into secant square x. So we have 0 to pi over 4, then tan to the power 6x, then secant square x dx. Okay, then from here we can use u substitution. We let u be tan x because we know that the derivation of tan x will give us secant square x, where it will cancel one of these. Okay, and then the other one that is going to remain there, we're gonna solve it with this identity. So since we know sec square x is tan x plus 1. Okay, so let me write down what I meant. So we say let u equal tan x, then the derivation of u is going to be secant square x dx, isn't it? Then notice that secant square x dx, we can say is this whole thing there. Then we substitute du where there is that. Okay, then we get integral from 0. We can change the bounds as well. Okay, so let's change the bounds. If we change the bounds, if u is tan x, when tan is 0, we still have 0. Then when x is pi over 4, we get 1. So here we're gonna have 1. So we say tan is u, then we have u to the 6, isn't it? Then secant square x. Then this one, we replace it by du. So we have du. Now we are integrating in terms of u, but we still have that. This is where the identity will come in. Okay, so integral from 0 to 1 of u to the 6. Here we're gonna have this identity gives us tan square x plus 1, then du. So basically you have integral of u to the 6 of u square plus 1 du, since we know that tan is u. Okay, so we're integrating u to the power 8 plus u to the 6. So from 0 to 1 du. So this one will give us 1 all over 9 u to the power 9 plus 1 all over 7 u to the power 7 from 0 to 1. If we plug 1 there, we're going to get 1 all over 9 plus 1 all over 7. If you plug 0, everything will just become 0. Okay, so now to solve this one, what are we gonna get? We're gonna get 7 plus 9 all over 9 by 7. 9 by 7 is 63. So we have 7 plus 9 is 16 all over 63. So that is the solution to that integral. Okay, so guys, thank you very much for watching the video. I hope it was helpful, and I will upload more videos on integration. I will upload about partial integration, trig substitution, and we do more problems. Okay, thank you very much. Don't forget to share and subscribe.